Now that you know the tan ratio, there are two other ratios that can come in handy too, because the tan ratio involves opposite over adjacent, right? Tan of your angle is opposite over adjacent. But what if you know or want to know your hypotenuse? In those cases, you might want to use the sine ratio, which is opposite over hypotenuse, or the cosine ratio, which is adjacent over hypotenuse. And to remember these, you can think of this memory aid tool, SOHCAHTOA. So sine is opposite over hypotenuse, OH. Cosine is adjacent over hypotenuse, AH. And tan is opposite over adjacent, OA. If you're trying to solve one of these, you might have to decide which ratio is suitable to use. So if you're solving for a side length, you want to use a ratio that involves both a known of yours, so something you know, plus your unknown side of interest. If you're trying to solve for an angle, you need to choose a ratio that involves two known sides. So for example, here we're asked to solve for side length x. We've been given this 55 degrees, so that's our target angle. And relative to that angle, x is our opposite side, and this 25 is our hypotenuse. So we know our hypotenuse, we want to know our opposite, so we're looking for a ratio then that involves an O and an H. And so looking at SOHCAHTOA, we see that that is the sine ratio. And that's what they've done down here. So we know sine of any angle is opposite over hypotenuse. So sine of 55 degrees then is x over 25. Then we can rearrange to solve for x by multiplying by 25. And we get x is 25 times sine of 55, which we can calculate to get our answer here. Remember, sine of 55, that's just a ratio. It's a number. We can calculate that in our calculator. Okay, let's look at the next example. So here we've been given this target angle 25 degrees. So relative to that angle, 13 is our hypotenuse, and x is our adjacent. So we want to use a ratio this time that involves adjacent and hypotenuse, so A and H, and that would be cosine. So cosine is adjacent over hypotenuse. That means that cosine of our target angle 25 degrees is x over 13. And then we can multiply both sides by 13 to get x is 13 times cos 25. And then using our calculator, we can calculate that out, and we get 11.78. Okay, so that's solving for side length. So you want to use the ratio that involves your unknown of interest as well as your known side. The other thing you can do is solve for an angle. So in this example here, we're asked to solve for angle x. Relative to that angle, we've got a side given over here, which is our opposite, and we've been given our hypotenuse. So we've been given O and H, which means we want to use a ratio involving O and H, and that is sine. So we know sine of any angle theta is opposite over hypotenuse. So sine of our unknown angle x then is 3 over 15. So we can figure out the decimal of 3 over 15. The decimal equivalent is 0.2. And then remember to solve for the angle. We take the sine inverse of both sides. That gives us x is the sine inverse of 0.2. And so if you do that on your calculator, you'll get an answer of 11.5. Okay, next question. So step 1, always label your triangle. So relative to this angle x we're trying to solve for, we've got 36 centimeters, which is our hypotenuse. And then this 28 would be our adjacent side. So we're looking for a ratio that involves adjacent and hypotenuse, which is cosine. So cosine of any theta is adjacent over hypotenuse. That means cosine of our angle x is 28 over 36. You can use your calculator to find the decimal equivalent of that. And then to solve for the angle, you're going to take the cosine inverse of that angle to get 38.9 degrees.